Okay, I guess the recording has started. All right. So good evening, everyone. Let me just join from the other account. Just give me a second. All right. I hope I'm clearly audible to you. Now I'm presenting the screen. Please let me know whether it is visible or not. So today, what we will do, we'll take a recap of the last lecture, whatever we have seen in the last lecture, network analysis. So we'll take a recap of that, and we can see transmission parameters and inverse transmission parameters. So in the last class, we have seen two port networks. So there are certain parameters that we have to calculate on two port networks. So those are Z parameters, Y parameters, H parameters. H parameters are also called as hybrid parameters, H inverse parameters. After that, transmission parameters and inverse transmission parameters. These things we are going to learn in today's class. Okay. So how do we remember this? So for Z parameters, we have initials V1, V2, right? When V1, V2, we have, these are dependent variables, right? V1, V2 are dependent variables. And here I1, I2 are independent variables that we have already discussed. Now V1, V2 for Z parameters, I1, I2 for Y parameters, V1, I2 for H parameters, and I1, V2 for H inverse parameters. Now what is remaining? Transmission parameters. So for transmission parameters, we have V1, I1, and for inverse transmission, we have V2, I2. So we have seen Z parameters, Y, H, H inverse. Now we'll directly go to the transmission parameters. So first of all, let me just go to the slide. I will share this PPT with you once the class is ended. So yeah, so formula for transmission parameters is V1 is equals to A V2 minus B I2, and I1 is equals to C V2 minus D I2. So we have to calculate the values of A, B, C, and D here when question is given. So for that, I will take one question and then we can calculate transmission parameters for that question. All right. So this is a resistance. I have another one resistance here, and there is a third resistance here. Here we have one dependent voltage source. Here again, I have one resistance, and this is ground line. Then we have a dependent current source here, again a resistance here. Values are 3 ohm, 1 ohm, 2 ohm. Its value is 2i1, its value is 2v2, 2 ohm, 1 ohm. This is input port, that is V1, and we have voltage V2 at output port. Current I2 should be flowing through this, and current I1 should be flowing through this. So first thing, or the first step to calculate transmission parameters is to calculate Z parameters, or like get the formulas for Z parameters. Okay, which is very easy. What we have to do to get Z parameters, we have to just apply KVL at input side and KVL at output side. Okay, so we'll do more things, or we'll do some analysis of this circuit to find out Z parameters. How do we do that? See, current I1 is flowing here, current I2 is flowing in this branch, this one, and current 2i1 is coming from this branch, right? So what can be the current from this in this branch? It should be 2i1 plus I2, right? Now I1 is coming from here, and 2I1 plus I2 is coming from here. So what should be current through this branch? It should be 3I1 plus I2. I hope it is visible to you. Otherwise, I will just zoom in. Okay. Now it is quite easy to apply KVL. So can you please apply KVL at input and output side? Please try it. I'll be also solving with you. So here we are going to apply KVL. So we'll start with V1 or minus V1. So my one minus V1 is plus, this is plus minus 3I1, 3 into I1, 3I1. Then we come here. This is a dependent voltage source. So we'll take its value as it is 2V2. Then we come here, and current flowing through this resistance is 3I1 plus, I will write it again, 3I1 plus I2. So voltage across it should be 6I1 plus 2I2. So that would be equal to 0. We have applied KVL here. Voltages of all the sum of all the voltages is equal to 0 here. So if we simplify this to calculate Z parameters, like formula for Z or the initials are V1 and V2, we have to calculate V1 here. So we'll take just V1 to the other side, 3I1 plus 6I1, that is equals to 9I1. Then we have 2I2 plus we have 2V2. Actually, V2 is not needed here, but it is here, so let it be. No issues with it. Okay. Now we'll apply KVL on the output side. How do we apply KVL on the output side? Now see, current through this branch is going to be like 0. Okay. Current through this branch is going to be 0 actually. So wait, yeah. Voltage across this should be 2I2. All right. And we have to apply KVL in this branch, in the outer branch. Okay. So how do we apply that? Let me just write it. Minus V2. I'm starting from here. Then we have 2I2, that is this one. Then we have 2I2, sorry, 2I1 plus I2, this one. Now I'm applying KVL to this outer loop, not this inner loop. Okay. I'm applying KVL here. So I have to consider this voltage. So it is 2I1 plus I2. Now this is done. We'll come here. We have to add 2V2 here. So it is again 2V2 plus this one. That is 2 into 3 is 6I1 plus 2I2 is equals to 0. Now we'll simplify it. V2 would be equal to, this is I1, this is I1 term. So it would be 8I1. After that, this is I2, this is I2, this is I2. So 2I2, 3I2, 5I2. 5I2, and this is 2V2. So let it be 2V2 here. So if this 2V2 goes here, it would be V2 minus 2V2 is equals to 8I1 plus 5I2. So minus V2 will be equal to 8I1 plus 5I2, and V2 is equals to minus 8I1 plus 5I2. So we have got the formula for V1 as well as V2, but we have to modify the formula for I1 and V1 because we are calculating transmission parameters. Okay, what formula we need? We need formula in this format. V1 is equals to AV2 minus BI2. So can we change any of this formula to get the formula like this one? No. As of now, we cannot change any formula like this. But if you consider this second formula, here we have V2, I2, and I1. That means this formula can be changed in the form of I1 is equals to XYZ. Okay. So how do we do that? Just keep I1 aside and all other terms aside. So it would be 8 I1. I'm taking 8 I1 here. Then minus V2 plus 5 I2. I'm just interchanging this. Again, I1 will be equal to minus 1 by 8 V2 plus 5 by 8 I2. So we have got the formula for I1. Now, if you compare this formula of I1 with this one, I1 is equals to CV2 minus DI2. So what is the value of C here? Value of C will be minus 1 by 8. Now what is the value of D? Can you please tell me what is the value of D? See, compare this formula with this one. What is the value of D?
minus 5 by 2.
Minus 5 by 2 or minus 5 by 8?
Yeah, minus 5 by 8, sorry.
Yeah, it should be minus 5 by 8. Why minus? Because it is minus D here, and here we have positive 5 by 8. So its value should be actually negative. So D is minus 5 by 8. Now, this is the formula for I1. How do we get formula for V1? How do we get that? So if you can see in this formula, we have I1, I2, V2, and V1. Okay, but from this formula, what is not required? Which is that term that is not required? See, V1 is here, V2 is here, I2 is here, but I1 is additional here. I1 is not necessary in this formula, right? So for that, what we will do? We will eliminate I1. How do we eliminate I1? We'll put this value in place of I1. I1 is equals to minus 1 by 8 V2 plus 5 by 2 I2. So we'll replace this value. So first of all, let me just write this formula here. That is V1 is equals to 9 I1 plus 2 I2 plus 2 V2. So I1 is not necessary. So what we are going to do? We are going to replace it. So V1 is equals to 9 as it is. In place of I1, I will write 1 by 8 V2 minus 5 by 8 I2. All right. Should be like this. Sorry. Yeah. Or it is positive. Yeah, it is positive here. So it should be positive, guys. All right. And then plus 2I2 plus 2V2. Now solve further. It would be minus 9 by 8 V2 plus 9 5s are 45 by 8 I2 plus 2I2 plus 2V2. So combine these terms. How do we combine this? V1 is equals to minus 9 plus 16 divided by 8 V2 plus 45 plus 16 by 8 I2. I hope it is clear to you. So V1 will be equal to 16 minus 9 is positive 7 by 8 V2 plus 45 plus 16 is 61 by 8 I2. So what is our A? A is 7 by 8 and B is minus 61 by 8. I hope it is clear to you. Transmission parameters. Any doubts? Any doubts, guys? I know it like it is very complicated kind of a thing, but this is what we have to deal. Okay, no doubts. Thank you. Okay, all right. Guys, although I'm trying to cover the basic parts, like all the basic parts of the syllabus, but in case if I miss some part, so you can suggest me, sir, please can you cover this topic? Okay, I'll try to cover all the things. Now, my like planning is we are going to end the subject network analysis and control system in this month, July, or in the first week of August. Then we'll take another two subjects, and then we take another two subjects like this. We are gonna go. Okay. So yeah, so this was just a refresher. This was transmission parameters. Now for inverse transmission parameters, formulas are same. There's just a slight change. We have to like we just have to uh, change the techniques little differently. Okay, so I'm not gonna explain examples and all for inverse transmission parameters. So for inverse transmission parameters, formulas are, it would be v2 is equals to a dash v1 minus b dash i1, and I2 is equals to c dash v1 minus d dash I1. So this is the formula. These are the formulas for inverse transmission parameters. Now, as I told you in the last class that we are going to take some complex examples as well. So I would like to focus on those rather than these formulas and examples. Okay. So sometimes what happens, you get this networks or two port networks in series or in parallel or in cascade, so combination of the circuits. Okay, so in such cases you don't need to calculate each circuit separately. There are certain things that if you follow those, you will get answers very quickly. Okay, so we'll see how these things work, how we put the two port networks in series, how we put two port networks in parallel, and how the parameters work, like how the parameters behave, what happens with z parameters, what happens with y parameters, that we are going to see. Okay, now what is means by the two, two networks are in a series? What does it mean? Basically it means, like, see, if this is a network, this is a two port network, and current I1 is flowing through this, current I2 is flowing through this is I1, this is I2, this is two port network, this is V1, this is V2. Now current I1 is going through this branch and coming back from this branch. I2 is going in this branch and coming back from this branch. All right, so this is our general network. Now when we put the circuits in series, so the basic phenomena should not change. Like if you say, sir, can I put like this is network 1 and this is network 2, are these in series? Are these in series, guys? Do you think these are in series? What is your opinion? It is not like resistance or any other element. They have only two terminals, but here we have four terminals. So we have to think, how do we connect them in series? This arrangement will not be called as series arrangement. This will be cascade arrangement. What it will be? It will be a cascade arrangement. Now, what is series arrangement then? See, let us suppose this is a network 1, this is a network 2, I1 is going here, same I1 is coming back from here, and then again it is going here, and then coming back from here. So this is in series. Similar for I2 as well. I2 is coming from here and it is going out from here. This is V1 and this is V2. So this is two port network in series. Okay, remember this. Now let me just give the heading: series arrangement. Now parallel arrangement. What is parallel arrangement? In parallel arrangement, voltage across both the terminals should be equal. Voltage across both the terminals should be equal. Let us suppose this is a network N1, this is a network N2, and these are two ports, input ports, and this is input port and output port. So similar, it should be connected to this, it should be connected to this, and this should be connected here, and it should be connected here. So this is called as a parallel arrangement. Now cascade I have already told you. Okay, so if you see these kind of arrangements, you can use certain tricks. So what are those tricks? Let me just tell you. If let us suppose, now we are talking about input and output. Okay, guys, see here, input is in series and output is also in series. Here also input also in parallel, out as well as output is also in parallel. But it is not necessary like input and output both are in either series or in parallel. It may be like input is in series, output is in parallel, or output is in series and input is in parallel. It may change. So in such cases, what do? We have to take into the consideration. Like see, if I give you an example of the circuit, let me just draw the circuit. This is a network 1, this is a network 2. Okay, and so its input is in series, but I'm keeping its output in parallel. Okay, so this is the example of series. Input is in series, input in series, but output is in parallel. So why I'm telling all this to you? Let us suppose, let me just take a new tab here because we are running out of pages. Just a second. All right, so I guess new tab is visible to you. Okay, so what I was talking about, yeah. Let us suppose your input is in series as well as output is in series. In that case, Z parameters get added. Okay, now Z11, Z12, Z21, Z22, we have calculated these things, right? So Z11 will be getting added with the Z11 of other one, other network. Okay, so you have to just add these parameters. But remember, when input and output both are in series, only Z parameters get added, not any other parameters. Okay, like let us suppose two networks are given and they are in series, and you have been asked to calculate Y parameters for that network. All right. So what you will do, you will calculate Y parameters for one network, Y parameters for other network, and you will add them. So that won't work. You have to calculate Z parameters for both the networks, add them, and then convert them into Y parameters. Okay, are you getting my point? What I'm trying to tell you, you have to add Z parameters when input and output both are in series. Okay, now the next point is if input is in parallel and output is again in parallel, then in such case Y parameters get added. Okay, Y parameters get added. Then we have input in series but output in parallel. In such case, which parameters will get added? Can you guess? Input is in series, output is in parallel. Which parameter might get added? Any idea? No idea? It would be obviously H parameters, hybrid parameters. Are you getting it or not? Okay, it would be hybrid parameters. So H parameters will get added. Don't worry, guys. Whatever I'm telling you theoretically, we will apply this into the examples as well. Don't worry about it. Okay. Next, what would it, what it would be? It would be input in parallel, output in series. In such cases, H inverse parameter will get added. Okay. Now, what if, like we have seen for input parallel and series, what if the parameters or what if the networks are cascaded? We haven't seen for that. Okay. So what if the networks are cascaded? When we cascade two-port networks, two-port networks, then its transmission parameters, that is A, B, C, D, that is A, B, C, D. There is a matrix multiplication of those parameters. Now, how does this work? Let us suppose see. There is a network 1 for which transmission parameters are A1, B1, C1, and C2. And there is network 2 for which transmission parameters are A2, B2, C2, and D2. Here I need to write D1. My bad. Okay. So these two networks are in cascade. So what it will be? It will be a matrix multiplication. So for the resultant network ABCD will be equal to, it will be a matrix, and it will be equal to matrix multiplication of these parameters. I hope you can calculate matrix multiplication, right? First row, first column, then first row, second column, then second row, first column, second row, second column. This is how we calculate, right? So this is for if the networks are in cascade. Now let me just give you one example. Give it a try and tell me which parameters should be added and what can be the result. Okay. So sorry, I have a simple circuit here. That is, this is V1, V2, this is 2, 3, and 1. Then again, I have a network like this is 2, this is 4, and this is 1. So this is I1, this is I2. Can you tell me which is this arrangement? Series arrangement, parallel arrangement? Which is this arrangement? Can anyone? Can anyone? Can you guys hear me? Shardul, Akhil, Raman, can you guys hear me? All right. Okay. So can you think what I'm asking you? Like, do you have any idea how do we proceed? So this is a parallel arrangement. Sorry for the spike in my voice. So this is a parallel arrangement. Don't you think so? Is it a parallel or series? This is a parallel arrangement. That is first thing we have to understand. Now, when there is a parallel arrangement, in such case, what happens? Y parameters get added. Okay. So let us suppose we have been asked to calculate Y parameters for this entire circuit, resultant circuit. Okay. So what we will do, we will calculate Y parameters for one circuit separately and y parameters for other circuits separately, and then we can directly add them, and then we can proceed, or then we can get the resultant y parameter. Okay, now let us suppose if you want to calculate y parameters or z parameters for this entire circuit without splitting the circuit, that would be a quite tedious and problematic job for you. So it is better we split the circuit, we calculate the parameters separately, and we add them. Okay, so let's proceed further. Take this circuit 2, 3, and 1. This is first circuit. Calculate y parameters. Calculate with me, everyone. This is V1, V2, I1, 2, 1, 3. This is I2. So this is negative, positive. V1 will be equal to 2I1 plus, this is I1, 2I1 plus I1 plus I2. That is equals to V1 is equals to 3I1 plus I2. Okay, now applying KVL here, it would be V2 is equals to 3I2 plus I1 plus I2. That is V2 is equals to I1 plus 4I2. So these are Z parameters. We have calculated Z parameters for circuit 1. Okay. Now we have to convert this into Y parameters. How do we convert? How do we convert it? For Y parameters, we need equation in the form of I1 and I2. Okay, I1 and I2. So try finding it. How do we find out? For I1, let us suppose we want to calculate equation for I1. So I1 is required, V1 is required, V2 is required, I2 is not required, right? So for that, what we have to do? We have to multiply this equation first by 4. So it would be 4 V1 is equals to 4 3s are 12 I1 plus 4 I2, and V2 is equals to I1 plus 4 I2. Now we are going to do the subtraction thing. All right. So when we subtract, sign changes. 4 I2 gets cancelled. 12 I1 minus I1 is 11 I1 is equals to 4 V1 minus V2. So I1 will be equal to 4 by 11 V1 minus 4 by, sorry, 4, not 4, 1 by 11 V2. So this is the thing. Okay. So what is our Y11? Y11 is 4 by 11. Y12 is minus 1 by 11. Right? Right or wrong? Am I going right, Raman? Akhil? Shardul? सही कैलकुलेट कर रहा हूँ ना मैं? Guys, do you really understanding it or not? Let me ask you frankly. Okay, you're understanding ना? Okay, fine. So like मतलब मैं सॉल्व करते जा रहा हूँ और आपको समझ में नहीं आ रहा, तो ऐसा नहीं होना चाहिए. Yeah. So you know what we are doing. Fine, thank you. So we have y11, y12, but still we need to calculate y21 and y22. How do we calculate that? For that, we need equation of I2. We need I2, we need V1, we need V2, we don't need I1. So we have to eliminate I1 here from these equations. So how do we eliminate I1? So first of all, I will write first equation as it is. That is V1 is equals to 3I1 plus I2. I have written the first equation as it is. I have to eliminate I1. So that's why I will multiply this equation second by 3. So 3V2 is equals to 3I1 plus 4 3s are 12 I2. 12 I2. So again subtraction thing. I1 get cancelled. So V1 minus 3V2 is equals to minus 11 I2, right? So I2 will be equal to minus 1 by 11 V1 plus 3 by 11 V2. Any one of you, if I'm going wrong at some point of a time, you can turn on your mic and tell. Okay, there's no problem. But as of now, I think we are going good. So y21 will be equal to minus 1 by 11 and y22 will be equal to 3 by 11. So we have found out the y parameters for first network only. These are y11, y12. This is y21, y22. Let me just highlight them. Okay. Now we have to again draw the second network as well. And for second network, we have to calculate y parameters. Okay. So second network is we have 4, 4, 1, and 2. 4, 1, and 2. These three resistances are there. So this is 4 ohm resistance. It was, I think, 1 ohm resistance, and it is 2 ohm resistance. So again, we have another network. Similarly, V1, I1, I2, V2, 4, 1, and it was 2. Okay. So try calculating. Try calculating. Calculate Z parameters at least, guys. Then we can. Then I will proceed. Calculate Z parameters for this. Then I will calculate Y parameter for this. Then we will add Y parameters, and then we are done for the example. Everyone, please give it a try. Till then, I will take a rest of 1.5 minutes. Guys, please calculate Z parameters. Okay, Shardul has got the answers, all right. Okay, Shardul and Raman. Akhil, what about you? You also got the answers? If yes, we can proceed with those answers. Okay, okay, fine. So, first equation is V1 is equals to 6I1 plus 2I2. And second equation is V2 is equals to 2I1 plus 3I2. I will write them. All right. V1 is equals to 6I1 plus 2I2. 6I1 plus 2I2. And V2 is equals to 2I1 plus 3I2. 3I1 plus how much? Sorry, it was 2I1. 2I1 plus 3I2. All right. So again, we need equations for y parameters, that is in the form of I1 and I2. So for equation I2, sorry, for equation I1, we don't need I2. So we'll simply multiply this equation by 3, this equation by 2. So I2 becomes 6 and it can be eliminated. So 3v1 is equals to 6 3s are 18 I1 plus 2 3s are 6 I2. 2v2 is equals to 4 I1 plus 6 I2. Now if we subtract this, I2 gets cancelled it will be 3v1 minus 2v2 is equals to 14i1, and I1 will be equal to 3 by 14 v1 minus 2 by 14, or simply we can write 1 by 7 v2. All right. So here y11 is equals to 3 by 14, y12 is equals to minus 1 by 7. This is how. Now from these equations we have to calculate I2 as well, right? I2 as well. For I2 we don't need I1. So how do we eliminate I1? For that we can multiply this equation second by 3. So I will write it here only. V1 is equals to 6 I1 plus 2 I2, and multiply this complete equation by 3. So 3v2 is equals to 6 I1 plus 9 I2. After subtraction, sign gets changed. 6 I1, 6 I1 gets cancelled. V1 minus 3 V2 is equals to minus 7 I2. All right. So I2 will be equal to minus 1 by 7 V1 plus 3 by 7 V2. So Y21 is equals to minus 1 by 7, and Y22 is equals to 3 by 7. So this is the answer. This is not the answer. These are Y parameters for the second circuit. Now we can add these parameters directly with these parameters so that we get resultant Y parameters for the what we can say, resultant parameters for the entire circuit. Now what is advantage of doing all these things? Why we are depending upon Y parameters only? Let us suppose आपको पूछा गया है कि ट्रांसमिशन पैरामीटर्स निकालिए. Okay, transmission parameters निकालिए. So in that case also you have to find out Y parameters first. Why? Because you have to do the addition. ये नेटवर्क जो है ये पैरेलल में है ना, ये दो दो नेटवर्क जो है वो पैरेलल में है. तो जब नेटवर्क पैरेलल में रहेंगे तो आपको कोई भी ट्रांसमिशन, कोई भी पैरामीटर पूछा जाए आपको उसको पहले वाई पैरामीटर में कन्वर्ट करना पड़ेगा, उसको ऐड करो, बाद में जो इक्वेशन मिलेगा उसको मॉडिफाई करके आप प्रोसीड करो. सिमिलरली अगर सीरीज में रहेगा, ट्रांसमिशन पैरामीटर निकालने के लिए भी पूछा है लेकिन सर्किट सीरीज में है, तो पहले जेड पैरामीटर्स निकालना है, उसको ऐड करना है, एंड देन वी हैव टू कन्वर्ट दोज इक्वेशंस इनटू रिलेवेंट इक्वेशंस. उसको किस किस तरह से करते हैं वो हमने अच्छे तरीके से देखा है इस क्लास में भी, पिछले क्लास में भी. ओके, so yeah, that is being said. Now what is next topic for the day? Let me just see. Okay, so there are certain things that I wanted to tell you about these parameters. Like there is a concept called a reciprocal network or symmetric network. So it is very rare chance that in gate examination such type of question will be asked, but for your safety purpose I'm just telling you, we judge the networks based on the parameters. Okay, so whether this network is a reciprocal network or symmetric network, these are just terms. Okay, you don't have to go into much depth of it, you just have to remember the parameters. So this is reciprocal or symmetric, that's it. Okay, so let us suppose you have z21 is equals to z12. You have z21 is equals to z12, so it is called as a reciprocal network. It is called as a reciprocal network. And if you have z11 is equals to z22, then it is called as symmetric network. This is for z parameters. Now for y parameters, y21 is equals to y12, then it is reciprocal. It is same as z parameters, like it is not different. and y11 is equals to y22 is there, then the network is called as symmetric network or the symmetric circuit. For h parameters, for h parameters, if h12 is equals to minus h21, remember the sign convention, so then it is called as reciprocal network. And if del h is equals to 1, if del h is equals to 1, that is called as symmetric network. Now what is del h? Delta or determinant of the h parameters. What it will be? Delta h will be equal to h11, h12, h21, h22. So this is delta h. If its value is equals to 1, then that network is said to be symmetric network. All right. And now for the last parameters, that is transmission parameters. For transmission parameters, if delta is equals to 1, del t is equals to 1, then it is reciprocal. Now what is delta? Here delta t is equals to nothing but a, b, c, d. If it is equals to 1, then that network is called as reciprocal. And if a is equals to d is there, if a is equals to d is there, then that network is called as symmetric network. Okay, so these are the things about two port networks that we need to remember. There is one more type of example, guys. I wanted to take it today, but it is quite lengthy example. I don't think we can cover it in 12 minutes. Okay, so only that example is remaining, and I'm damn sure that that kind of example can be asked in the examination. Okay, it has been asked like 2 or 3 times last time. Okay, so I will take that example. With that, our two port network part is finished. After that we will start transient response. Okay, introduction to transient response in the next class. So we'll be having one example of two port networks, and then we'll start transient response. Guys, tomorrow we will be having the class of control systems, and please don't miss it. Okay, because I think we're going to start a new topic, and that is going to be really important for you. And please don't miss it. Okay, yeah, fine. So that's it for today, guys. I think you can leave the class now. Thank you. Bye bye. Good night. Yeah, guys, good night. Bye. Thank you.